Hi everyone. Today we'll have a look on what is inheritance and why we go for inheritance. Inheritance is one of the key features of object-oriented programming. It allows the user to create a new class, that is a derived class, from an existing class, which is the base class. The derived class inherits all the features from the base class, and it can also have additional features of its own. As we see here, child inherits all the properties from its parents, which is stated as inheritance. Next we will see what is base class and derived class. The class that is being inherited by other class is known as base class or superclass or parent class, whereas a class that inherits another class is known as derived class. It is also called as child class or subclass. Next comes the advantages of inheritance. First is code reusability. Here you can reuse the members of the parent class. There is no need to define the members again and again. So only less code is required in this class, which reduces the chances of error and data redundancy. Next is extendability. Here you can modify or add new attributes and behaviors defined in the other class. Thus extending is possible here. Therefore, it appears to be in a more readable form and faster implementation is also possible. Now we'll see why we go for inheritance. Consider a group of vehicles, say a bus, car and a truck. You need to create classes for this. The methods or the functions, that is the fuel amount, capacity and braking system, will be same for all the three classes. Without inheritance, if you try to create these classes, then you have to write all these functions in each of the three classes as shown in the top figure. Here you can clearly observe that the process results in duplication of the same code 3 times. This increases the chances of error and also data redundancy. To avoid such situation, inheritance can be used. Here we create a base class, that is a vehicle class, and write these three functions in it and inherit the rest of the classes, that is derived class, from the vehicle class, which is the base class, which can simply avoid the duplication of data and also increase reusability. In the bottom figure, we observe that the three derived classes are inherited from the base vehicle class. Here comes another example where the usage of inheritance is insisted. Suppose in a game there are three characters, say a maths teacher, a footballer and a business person. Since all the characters are humans, they can walk, talk, eat and drink. Apart from this, they also have their special skills, where a maths teacher can teach maths, a footballer can play football and a business person can run a business. You can individually create these three classes who can walk, talk and perform their special skills. In each of the classes, you can be copying the same code for walking and talking for each character. If you want to add a new feature like eat, you need to implement the same code for each character. This can easily become error prone when copying and duplicating codes. To avoid such errors, we use the concept of inheritance. With the help of inheritance, it would be a lot easier. Here we create a base class with basic features like talk, walk, eat and add special skills to these features as per our characters in the derived class. Therefore, by using inheritance, now you don't implement the same code for walking, talking and eating for each class. You just need to inherit them from the base class. For maths teacher derived class, you inherit all the features of a person base class and add a new feature teach maths. Likewise, for a footballer, you inherit all the features from the base class person and add a new feature play football. Similarly, for the derived class businessman, all features are inherited from the base class person and special feature run business alone is added to it. This makes the code cleaner, understandable, extendable and more error-free. It is important to note here that when working with inheritance, each derived class should satisfy the condition whether it is a base class or not. In this example, maths teacher is a person, footballer is a person and businessman is also a person. You cannot have businessman as a business. Next, we'll see about the different modes of inheritance. When creating a derived class from a base class, you can use different access specifiers to inherit the data members of the base class. These can be public, protected or private. When the member is declared as public, it is accessible to all the functions of the program. When the member is declared as private, it is accessible within the class only. When the member is declared as protected, it is accessible within its own class as well as the class immediately derived from it. The table shown here clearly summarizes the different access types according to who and how they can be accessed. Have a look on it. Here comes the syntax for inheritance. First, the keyword class is given, followed by the name of the derived class and a colon. Then the type of access specifier is mentioned. It can be public, private or protected. This is followed by the name of the base class. It is important to note here that if the access specifier is not used or stated, then it is considered to be private by default. The private members of the base class are never inherited. Next we see how inheritance is implemented. In this example, class person is a base class and the classes max teacher and footballer are the derived classes from person. The derived class appears with the declaration of a class followed by a colon, keyword public and the name of the base class from which it is derived. Since max teacher and footballer are derived from person, all the data members and member functions of the person can be accessible from them. Here is a simple program for implementing inheritance. In this program, we create a base class parent with data member which is declared to be public. Here, the child class is publicly inherited from the parent class. So, the data member of the class parent will also be inherited by the class child. Next, in the main function, only one object is created. The data members are accessed using dot operator with the object created. Have a look on this program and try to work it out on your own. Yet another simple example for implementing inheritance is given here. In this example, derived class car inherits both data members and member functions from the base class vehicle. Next, we look into an example of implementing inheritance using constructors. Here we have a base class teacher and a derived class math teacher. The math teacher class inherits the teacher class. So, the derived class can use the property college name of the base class. We very well know that constructor is automatically called when we create an object of the class. It is important to note here that when we create the object of the derived class, it calls the constructor of the derived class. And the derived class constructor automatically calls the constructor of the base class. Look at this output, it is clearly illustrated here. Thank you for watching this video. If you find this video to be useful, subscribe it and share it with your friends. Don't forget to click that like button because it will motivate me to post more videos. Thank you once again.